Dear viewers, welcome back to the TCE Learn Easy program on StatPro. Thank you very much for subscribing our channel and making it reach many. In this example, we will see a practical example, that is having a plan and how to model with the plan in the StatPro, how to give the loading, how to give the support conditions, analysis and design of a given plan. So let this be the given plan. Say this is kitchen and this is bedroom 1. The dimensions are given. This is hall of dimension 8 meters by 5 meters. Then we have the portico where car parking is there. Here bedroom 2, and here we have a staircase. So this is a plan. So let us see how to model this. So initially in a plan we need to locate the columns. So wherever there is a wall, the wall has to rest over a beam and beam has to rest over columns. So with that hint, we can place the preliminary arrangement of columns, and let the arrangement of columns be as shown in this diagram. So as soon as we arrive or locate the columns, we need to arrive the coordinates of each column. Say let us start here. So this is positive x-axis, this is positive z-axis, and vertical we have positive, vertically upward positive y-axis. So say here the coordinates 0, 0, 0. Actually we have only 2 coordinates, but 3 x, y, z need to be written. So y is 0, that's why it has not been mentioned. So 0, 0, 0, 5.23, 0, 0, 11.46, 0, 0. Similarly this 0, 0, 5.23, 5.23, 0, 5.23, and 11.46, 0, 5.23, and all the other coordinates are here. So we need to input these coordinates to form this frame. So let us see how to input this in the StatPro. So in StatPro, go to new, go to, give the file name, space frame, say space frame 9 or some number. Then this is the location, metric is chosen, click create. Then instead of going to structure wizard, we can enter the nodal coordinates. Say the first node has coordinate 0, 0, 0. Second node 5.23, 0, 0. Third node 11.46, 0, 0. Then fourth node 0, 0, 5.23. Then 5.23, 0, 5.23. Then 11.46, 0, 5.23. Then 0, 0, 10.46, 5.23, 0, 10.46, 11.46, 0, 10.46, then 5.23, 0, 14.69, 11.46, 0, 14.69. Then 0, 0, 17.42, then 5.23, 0, 17.42, then 11.46, 11.46, 0, 17.42. 17.42. So the nodes will be formed. We not visualize the nodes. Go to view, label settings, say node numbers, node points. So these are the column positions which we have arrived from the given plan. Now these are at the footing level. Now these points have to be raised to a height of 1.5 meters. That is, the foundation height is given in this problem as 1.5 meter. So let us see how to raise this. So we need to select all the nodes. So to select all the nodes, go to select, take the node cursor, then press Ctrl A to select all the nodes. Then we have in the geometry, we have this translation repeat option. So click translational repeat. So choose the y direction. Thus we are going to translate these nodes to a distance of 1.5 meter along y-axis, positive y-axis. Okay. So we need to give the spacing as 1.5. Then we need to select link steps. Click link steps because these points have to be connected. So click OK. Then so the columns to a length of or to a height of 1.5 meter are shown here. Now this is the plinth beam level. Say 15, 16, 17, 18, 19, 20. So this is the plinth beam level. So to draw the plinth beam, we need to cut at this level. That is, at the level of 15 we need to cut. So that cut section is available in utilities, structure tools. We have cut section. We need to cut along the XZ plane. So this is the XZ plane, this is XY plane, and this is YZ plane. So we need to cut along XZ plane, and we need to specify some node number at which the cut section has to be made. So you can specify either 15 or 16 or 17 or anything available in this level. So let us mention 15. So I need to cut at the level of node 15. Click and click OK. So it will be cut at that level. Now here we can draw the beams where we have plinth beams. You can draw. So go to geometry. Go to add beam option. So click on add beam option. So we are going to add beams between these two nodes. Similarly, between these two nodes. Wherever you have plinth beam, you need to come. So naturally at the outer we'll be having plinth beams. So let me connect all the outer columns first. So here similarly connect these two. Just click between click each node. Similarly this and this. Now with the plan you should see where will the plinth beam is required. Where is the plinth beam required? So for example, if it is required here, we can introduce here. If it is required here, I can add here. If it is required here, I can. So wherever we want, we can add the plinth beam using this add beam option. Similarly, I'm going to add between 21 and 22. Similarly here and here there's a plinth beam. So between this and this, between this and this. In case we have wall here, we can add or can leave. Say let us assume say wall. So plinth beams are connected now. Now we need to translate the entire thing to a height of, say the basement height is given as 0.6 meter and ceiling height is 3.6 meter. So we need to translate this to a height of 4.2 meters. So let us see how to do this. So for that, take the beam cursor take the beam cursor, press Ctrl A. All the beams will be selected. Now we are going to translate this to a height of 4.2 meters. So use translate option, go to geometry. Here we have translational repeat along y-axis. I am going to translate to a distance of 4.2 and see whether link steps are selected. Click OK. So now you can see how it's formed. To display the entire structure, go to view and click display structure, so it will show from the bottom. So we're going to design G+1, so this is ground floor, so one floor is above, so we need to form that floor. So for that, for forming that floor also we can use this translation repeat, but now we need to cut at this level, at the level of 29. So go to utilities, go to structure tools, have cut section, click XZ. Say now the node point is 29. I'm going to cut at the node point 29 level in XZ plane. Click OK. So now let us select all these beams by either by window selection or by pressing Ctrl A. So these need to be translated to a height of 3.6 meter. So go to geometry, translational repeat along y-axis. So we're going to repeat, say 3.6 translation repeat. Then click OK. The link steps need to be selected. Click OK. So now this is formed. So this is one of the method to form this frame like this. We have various methods to form the geometry, which we will be learning one by one by practice. So go to view, display whole structure. So this is the building frame which we have created. Say this is ground floor and this is first floor. In case if we have n number of floors here, if we have n number of floors here, then we can use the same translation repeat option and you can give the number of repeats. So if I want to repeat this for 8 times or 9 times, if you type 9 and the spacing, if I type it as 3.6 meters, then 9 number of floors will be generated. So this is a very good, very useful option to generate the floor plans or model the space frame. The next thing will be we need to give the member properties. So let us give member properties like say properties. Go to define rectangle. Say let us give 0.38 by 0.23. Say let all the plinth beams of be of this property. Let all the floor beams of 0.45 by 0.23. Let all the columns be of size 0.3 by 0.23. Add. So now I am going to give these properties to plinth beams, floor beams, and then columns. So go to view, go to front view. Then say this 0.3 by 0.23 is to be given for all the plinth beams. So we can make a selection like this. So this property is selected. Can have make a selection like this. Can ensure in the isometric view. So click the isometric view. So all the plinth beams are selected. I'm going to give this property. If every plinth beam is of different dimension, then we need to select one by one using cut section option. So we can cut at the plinth beam level. We can select the member properties and the members for which these properties are need to be given. So likewise you can do. So assign to select beams, assign, yes. So now the plinth beams are assigned this property R1. Now again take front view, click outside. So this 0.5 by 0.23 for the floor beams as well for the roof beams. So press Ctrl, you select this, similarly select this. Go to isometric to ensure the selection is correct. So the selection is correct. So click assign to select beams, click assign, click yes. Now the columns are to be selected. So the easiest way to select all the columns is to go by select, before that select the property. So this 0.3 by 0.23 I'm going to give for columns. So select this member property, go to select option, beams parallel to Y. So you can select all the columns like this. Then assign to select beams, click assign, click yes. Now almost all the member properties have been assigned. To ensure that we can see, go to view and 3D rendering option. So this is the frame which have been created. So there are some other methods, easiest methods which we can learn by experience. So this is one basic method of creating the frame with a given plan. Now the member properties have been given. Now we need to give the support specifications. So take the front view again. So go to supports, go to create, say fixed support, add, then the supports chosen, the supports are to be selected. So form a window like this and see whether everything is, all the bottom supports are selected. Then click assign to selected nodes, click assign, click yes. So the support condition is formed. Next is loading. So click loading, click load case details, click add. First let us give dead load, so click dead. Click add. Then number 2 will be live load. Click add, close. Under dead load, click add. So we are going to give self weight, so -1 along y direction, click add. And then the self weight of slab, the self weight of slabs will be considered as dead load. So let the slabs be of 150 mm thick, therefore the load will be 25 kilonewton per meter cube, that is unit weight of RCC multiplied by thickness 0.1 will be 3.75. So let us give the floor load of minus 3.75, minus 3.75 kilonewton per meter square. We need to give the Y range. So Y range will be, say, at this floor level, that is the floor level or ground floor roof, as well first floor roof, we are going to give the slab thickness, or sorry, slab, the sulfate of the slab. So it starts at a height of, say, this is 1.5 and this is 4.2. So it starts at the height of 5.7. So the minimum range will be 5.7 and the maximum range will be 5.7 plus 3.6, so which will be 9.3, so up to 9.3. Click add. So it's added twice, so once one we can delete. So now we can see the dead load of the say this is the floor slab and this is the roof slab are shown. Sulfate has not been assigned, so click sulfate, select all the members by dragging the window, then click assign to selected members, click assign, click yes. So sulfate of beams and columns are given in this step. Then we will be having floor finish for floor slab and weathering course for roof slab. Let the floor finish be 2 kilonewton per meter squared. So that also we need to include dead load. So click dead load, click add. Say floor load. So let it be 2 kilonewton per meter squared. So -2. Range, Y range will be, so it acts at the this floor slab, so it will be 1.5 plus 1.5 this is, and this is 4.2, so 5.7. So 5.7 will be the minimum range. Similarly, maximum range will also be 5.7. Click add. Then the weathering course, so let it be -2.25. So the level is, weathering course acts at the level of 9.3 to 9.3. click add. So all the dead loads have been given. Close this. Now live load need to be given. So live load, say the floor live load is 3 kilonewton per meter square and the roof live load is 1.5 kilonewton per meter square. So click live load, click add, click floor load. So floor load will be -3 for floor slab, and floor slab height is at 5.3 meters because 1.5 plus 5.7 meters. So similarly at 5.7, click add. Then the roof slab will be -1.5 will be the live load. So the height will be 5.7 plus 3.6, 9.3. So this will also be 9.3. Click add, click close. So if we click this, the floor live load, and if we click this, this is the roof live load. So we hope we have given the dead loads, the self-weight of beams and the self-weight of the slabs, then floor finish and the weathering course at the roof level. Now live load, say this is for the floor slab and this is for the roof slab. Now we need to give the load combination. So go to load case details, click add, click auto load combination, select the code according to which the load combination has to be made, IS426, click generate loads, click add, click close. So this is how we should add all the loads. Then go to analysis commands, perform analysis, click all, click add, close. Then before going to the design, select all, go to design, select the material as concrete, select the code as IS426, select parameters, so bring all the parameters this side, then FC, FI main, FI secondary, maximum main, maximum secondary, minimum main, minimum secondary. As usual we do these steps. So what are the parameters according to IS code we need to given for the design? So FC, let M20 grade concrete be used. Click assign. Then let FE 500 bars be used. So for main reinforcement 500,000. So it's need to be in kilonewton per meter square therefore. Then FI secondary, say let it be 415 grade steel. So 415, FE 415,000 assign. Maximum main, say let it be 20 mm assign. Maximum secondary 12 mm assign. Minimum main 12 mm assign. Minimum secondary 8 mm assign. Now we need to select the beams and give the command as design beam. So go to select beams parallel to X, beams parallel to Z. So all the beams will be selected. Go to commands, click design beam, click assign, close. Now select beams parallel to Y, that is all the columns. Go to commands, design column, click assign, click close. Then you need to select everything, then go to commands, take off. That is, this will take the quantity of concrete as well the quantity of steel required for this space frame. Click assign, close. So this completes the pre-processing of the space frame for the given plan. With the given plan, we have generated this model and we have given the member properties. We have given the support specifications, loading analysis and design. Now the processing will be click run analysis. The process will start. So analysis successfully completed. Now we can see the design results. Say by clicking, say this beam, the reinforcement required, click on this, say 612, 312 here, 512 at the bottom, or you can give the minimum space, minimum diameter of rods is 16 mm, then it will be designing accordingly. So you can change, say it will be 316 here and 216 here and 316 here like this. Similarly, if column reinforcement is required, click on the column. So this is how you can design the. So thank you all for watching this video on space frame for the given plan. Please subscribe our channel and make it reach many. Thank you.